Hello everyone, welcome back. I am Vijay and today we are going to learn how to measure distances using an ultrasonic sensor and an Arduino. It's a fundamental skill for many projects. Measuring distance is also a key capability for robotics and a bunch of other exciting applications. So let's get started. Here is what we will be using today: an Arduino board, an ultrasonic sensor HCSR04, and a few jumper wires. Coming to the working principle of ultrasonic sensor, the ultrasonic sensor sends out sound waves and measure the time it takes to return back. This data allows us to calculate the distance of the obstacle. Let us browse the datasheet of ultrasonic sensor to understand the measurement cycle. We can look at the pulse cycle. It indicates that to initiate the cycle, the trigger pin is set high for 10 microseconds. 8 pulses of 40 kHz are emitted from the transmitter. The echo pin on the sensor goes high from low. The 40 kHz sound waves will bounce off the nearest object and returns to the sensor. The echo pin then goes low once reflected wave is detected, as these are shown in the datasheet graphs. If no object is detected, the echo pin will stay high for 38 milliseconds and then goes low. Now coming to the calculation part, we know the speed of sound is 343 meter per second at 20 degrees Celsius. Let x be the distance in meter of the object and time recorded is t second. Then t is the time sound wave takes to make a round trip to the object and back again. This time will cover 2x meter distance. So we can see that we can use the velocity is equal to distance by time formula, and substituting 343 meter per second for the velocity of sound, and then we finally get x is equal to 171.5 times time in meter. And if you want to get it into centimeter, multiply it by 100. And generally, in microcontroller, we use some function, built-in function to calculate time, and that time is given in microsecond. So if time is in microsecond, then the formula for x is 0.01715 into t in microsecond centimeter. Sometimes you may also come across a figure of 58.3 microseconds at various places. So do not confuse, this is the time for pulse to travel to an object at a distance of 1 centimeter and then return back to the sensor. So for that you can inverse this value, you will get 48.3. But never mind, we will be using the above expression of 0.01715 multiplied by the time measured in microsecond. So now it's time to connect the circuit. So we can connect VCC and ground to the VCC and ground of Arduino. Now we can connect trigger pin to any digital pin. In this case, I am using pin 7 and pin 8, echo pin to other digital pin. This forms a basic circuit for our distance measurement. Let us write the code to read data from ultrasonic sensor and calculate distance in centimeter, and finally to display it on the serial monitor. So open Arduino IDE, and then after declaring the trigger and echo pins, we set the pin modes for both these pins and start serial begin in the setup function. We also set the trigger pin low and wait for 2 microseconds to keep this ready for the trigger. In the loop function, we initiate the measurement cycle by setting the trigger pin high, followed by setting it to low after 10 microsecond delay. Next, we read the time in microsecond using pulse in function for echo pin till it is high. The pulse in function returns the value in microsecond. Calculate the distance in centimeter using the expression 0.01715 multiplied with the time in microsecond that we are getting in return to the pulse in function. We also add some print commands for the display of values on serial monitor, and we can add delay to observe the value displayed. So now let us upload the code using top left corner button, and let us see all these in action. So I'm changing the distance of the object manually that you can see in the video, and observe the changes in the distance values on the monitor. And that's it, a tutorial on measuring the distance of an object using ultrasonic sensor and Arduino. If you find this tutorial helpful, don't forget to like this video and subscribe for more such tutorials. Until next time, happy making. Thank you.